Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. And today we're doing chemistry. This is the chemistry videos that are for people who are going through taking this as a class. We are using this book, but if you just like the way I explain things, come on in, you can hear it. I also teach I have another playlist called Elements of Chemistry, and that really goes for students taking a different class where it is more targeted to them. So there's two different classes going on. This one is going to have all the lessons in order. The other one is sort of here and there, here and there. Now, something else I was going to say about that. Oh, we are not going to go through this whole book. There is a lot in this book that is more a Chem 2 level or an AP Chem level or a college chemistry level. You're welcome to do it. But for these videos that I'm making, if you're going along with me this year, we were gonna, for the rest of the semester, we're gonna do one video every 2 weeks, so you have time to really learn it and to do the labs, and then we're gonna quit. And so we are going to only do like 6 more weeks, counting 6 more videos, counting this one, 12 more weeks. I'm planning on making more videos that sort of finish out the book for those of you who want to do more and sort of do it like as another semester of advanced chemistry or Chem 2. But I'm not sure. And so we'll see. But right now I'm sort of thinking that in the summer when I have a little bit more time, I can finish out this book. But we're going to stop. We're only going to do, this is chapter 15, 16, 17, 18, 19, and 20. And because that's really about the scope and sequence of a normal first year chemistry class. But there's more in here and you're welcome to learn it, and you can probably just read it and figure it out. You probably don't need me. And also you can look at videos by Tyler DeWitt. He's a good one that's on YouTube. Mark Peterson is really good. He's got tons of chemistry videos that are at this high school level. And Mark Peterson's videos, it's Peterson Science is what you need to Google. His videos are AP, so they are the little bit harder ones. So if you want to go ahead and finish the book, you could just watch the Peterson Science ones and you would have it. All right. Okay, so what we're talking about today, we've been talking about bonding. And first we talked about ionic bonds, which is where an electron is transferred. And remember we talked about on the periodic table, it's the ones on this side who want to lose an electron and the ones on this side who want to gain an electron work out a deal. They lose, they gain, they become positive, they become negative, opposites attract, and you have an ionic compound like table salt. That's just our classic salt you can always think of. All right, so what about, and remember we talked about that all the different family groups, if you think about it as kids, these are the ones who lose their kids. These are the ones who get someone's extra kid, and like that. And we said that this group right in here, they're too far away from the ends to gain or lose, that what they do instead is they're the divorced parents who have custody arrangements and they share their little electron. Now, just like you probably know somebody who has divorced parents, if not you. And most divorced parents do not share their child equally. You don't go to mom's on Monday, dad's on Tuesday, mom's on Wednesday, dad's on Thursday. No, that would drive anybody crazy. So usually it's an unequal sharing arrangement. Usually mom has the kid more time than the dad, or sometimes it's the dad who has more time. I teach public school, and last semester I had a lot of kids who the dad had primary custody, more than I'd ever known people. I had all these dads who had the custody of the kids. So it could be the dad who has the child more. But it's unequal. So that's how it is with the electrons too. When they share the electron, it's called covalent. And unless the atom is the same, like say you've got 2 hydrogens sharing a pair of electrons, or 2 chlorines or fluorines, bromines, oxygen, nitrogens, it kind of makes an L, these that share with themselves, and they're gases usually. Then if they are the same element sharing the electrons, then it is exactly even. excuse me, they have the same strength to hold the electron to itself. So I was going to show you in a different book what this stuff is called. I was going to go ahead and teach you the words for it. I don't know if your book does or not, but extra learning at the same low price of free. All right, so here's the periodic table. Whoop. And on it, it shows what are periodic trends, okay? So first of all, we have electronegativity. And electronegativity is the ability of an atom to hold an electron to itself. And it goes down as you go down a column because it gets bigger and bigger, and it's harder to hold those electrons in tight because of something called shielding effect. I always explain this. It's like me and my sister. My sister had 6 kids, I only had 3. And that my sister would let her kids kind of get further away from her than me. You know, there were 6 of them. And in particular, she had this one fella named David. And if you're watching this, yep, I noticed. He was very smart. I'm not saying he was smarter than his brothers and sisters, but he might have been. Because if he did something bad, he would make sure that there was 2 or 3 kids between him and his mama, so he was not going to get punished. He was just too far away. Should just let that one go. And he was so smart. I would see him do this all the time. So he would use shielding effect in his big family to make sure that the power of the mama didn't reach him. When the atoms, it's the power of the nucleus. And the more electrons they have, the more there's electrons between the nucleus and the outer electrons, and they spread even further out. They have less power of that nucleus to hold them in tight. So that's why the electronegativity goes down as you go down a column. As you go across a row, the electronegativity actually increases, because as you remember, these want to lose their electrons, these wants to steal someone else's. So they don't want to lose any of theirs. So they hold their electrons in tight. So as you go across, it gets closer and closer and closer. And weirdly, the atom gets smaller and smaller and smaller because the nucleus is holding it in tight because it wants to keep all of its electrons and get someone else's so that it feels like a noble gas. And when I say feel, I don't think they really have emotions. It has to do with energy. Okay, so that is called electronegativity, the ability to hold the atoms to itself. Another aspect of all of this is really the same idea. The other idea is called ionization energy, and that's the energy it would take to take an electron off, to pluck one away. So of course, with these, ionization energy is very low. It's easy to take their electrons. They're like, here, take them. I don't care. They're all yours. But over here, ionization energy is very high because it does not want to lose its electrons. It's holding them tight, and they're not going to get plucked off. Okay, so that goes back to our ionic and covalent bonding ideas. And in particular, moving my books around, that's what this noise is. In particular, it has to do with this covalent sharing. If one of these has high electronegativity, ability to hold the electrons to itself, then it gets the electron more in the covalent bond. So like if you have oxygen with a high electronegativity and hydrogen low electronegativity, then the oxygen's the bully and gets to have the electron the most that makes the bond. The bond is the shared electron pair. And oxygen's going to hold it close, and hydrogen's not going to get it much at all. So in water, that's why water has that Mickey Mouse shape, where Mickey Mouse is unimpressed, straight line, because the oxygen is more negative because it gets the electrons more. Excuse me. I have my Alice in Wonderland teacup. If only I had a Mickey Mouse one, I could have said, look, like Mickey Mouse. So the more electronegative it is, they're the ones that gets the electron more in the covalent bond if they're not exactly the same. So if it's a single covalent bond, they share 2 electrons. If it's a double covalent bond, they share 4. If it's a triple covalent bond, they share 6. And your book says that a double bond is stronger than a triple bond. Once you get to organic chemistry and you learn about organic reactions in your second year of college, or you might get some organic if you take that Chem 2 or AP chemistry, you will learn that the place that is the most attacked and in a way the weakest, the place where it springs, is that double bond. So some things your book says, I'm like, what? Because, I mean, it's just not good. It's going to be where it breaks. So to me, if that's where it breaks, to me, that's weak. So I guess it depends on your definition of strong and weak. All right, so there are different ways to write these formulas. We can do the Lewis structure like what we learned before, where we draw a bond as 2 electrons, or we can draw 2 dots, or we can draw a line, and that also can be a bond. Sometimes you just draw them all straight, but other times you want to show the bond angles. So that also has a difference in how you're going to draw these. Let's see. The book talks about coordinate covalent bonds, and that's really more of a Chem 2 idea also. It's where sometimes making these double and triple bonds, even though they're sharing 6 electrons, one of the atoms might have contributed more of those 6 than the other ones. And there goes back to my family ideas. Like if you have a blended family, a mom and dad get married, and like the Brady Bunch, they had 3 and 3 of the Brady Bunch, but if the new marriage, the mom only has 2 kids and the dad has 3, all those kids get shared and they didn't contribute them equally. So just think of the Brady Bunch. I just saw a good show about the Brady Bunch redoing the house. That was interesting. I think it was on HGTV. Okay, so then there's also an idea called resonance. Sometimes the bond will be like a double bond on one side, single on the other, and then it'll go double on one side, single on another. And you can think of it as switching back and forth. It's called resonance. Really, it's just sort of unequally sharing smeared around, which you will learn more about in Algebra 2. Or college chemistry. We're not going to talk much about resonance. Just know that's an idea. Take a look at it in your book. Also, there are exceptions to the octet rule. Remember the octet rule that they all want to have 8 in their valence electrons in their outermost energy level, like the noble gases. Guess where you're going to learn more about that? College or Algebra 2. Same thing with molecular orbitals. College or Algebra 2. This is more about how the bonds actually form. There's something called pi bonds and sigma bonds. I'm drawing it for you. Pi bonds, sigma bonds. But that's really more than what we're going to go into in this class too. You're welcome to read it. And go watch Peterson. I'm sure he's got videos on this. Okay, now what is Vesper Theory? And then if we were together, face to face, I would give you a marshmallow and some pretzel sticks and tell you that the marshmallow is the nucleus and the pretzel sticks are the bonds. And the bonds are all negative because they're made out of electrons. And what do like things do? They repel, so they're going to try to get as far away from each other as possible. So first I would give you a marshmallow with 2 pretzel sticks, and you'd put one on each side, and you would make a linear molecule, meaning that if there's only 2 bonds coming out, they try to get as far away from each other and make a line. If there's 3, they make a peace sign, because that's the best way for them to spread out. If there's 2, it's 180 degrees. If it's 3, it's 120. But if you have 4, then I would say, what do you do now? And everybody would put them as a plus. And I'd say, no, 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 no. So how do you do it that's not a plus to get those pretzels to spread out the furthest from the marshmallow, each other stuck in the marshmallow? Well, what you do is you make it like a pyramid. You put 3 on the bottom like a little stool with 1 coming up, but you arrange them where they're all equally distanced away from each other, and that's a tetrahedral. It's 109 degrees away from each other, somewhere in there, and that's as far apart as it can go. And the pyramid's the same no matter how you turn it. And that is one of the secrets of life. You are a carbon-based life form because carbon bonds in these tetrahedrals, these very symmetric ways that make it where carbon can actually make millions of different compounds. We're still discovering them constantly, and it's why carbon is the element of life. So in your book on page 413, you see these, the linear, the peace sign is called trigonal planar. Bent is if you have the peace sign, but one end of it is a unshared pair. You can have electrons that are not shared. If you remember when we did Lewis structure, you can have two dots on one side that come just from the valence electrons of that element. Where it bonds is where there's just one electron, but you can have two. There won't be a bond. It'll be an unshared pair, and it's extra negative, and it shoves the other bonds it makes more away from it. Nitrogen does that. It's what gives water. It's Mickey Mouse shape. It's bent shape. Oxygen has two unshared pairs, and it pushes those hydrogens away. It gives it its bent shape and its polar nature. It makes water have a positive side and a negative side, and it makes water a sticky molecule. It makes water where it dissolves things into it. It makes it where trees can drink. And we're going to do a whole chapter on water, I'm pretty sure. And because it's water and carbon is what gives us life on this planet. And that's what the designer used to make the design to have life on this planet, whatever that designer is. Hybrid orbitals, once again, that's something you will learn in college and in algebra, not algebra 2, I just got through making a bunch of algebra 2 videos, in Chem 2 or AP Chemistry. Now, polar bonds, I already told you about that. It's where they're not shared equally. It gives it a positive and a negative end. Water is a great example of a polar molecule, and it causes it where it has certain properties based on that positive and negative end, especially with dissolving. And we're going to do a whole chapter on solutions, and we will talk more about that. Bond dissociation energy is the energy that's given off when a bond is broken. And that's like where the heat comes from when you're breaking bonds in reactions. There are something that are not quite bonds, but they're important. And there are molecular interactions. There's ones called dispersion forces, dipole interactions, van der Waals forces. But the most important of all of those is called hydrogen bonds. It's not really a bond, but it's because water has that Mickey Mouse shape, and the ears of hydrogen become positive and the head of oxygen becomes negative. It really gives it a very strong positive and negative end, and that causes it where water can dissolve things. It's why salt dissolves in water. It's why it's how trees drink and why water beads up. And one of the things that cause life on this planet from it is that when water freezes, it has to line up in a certain way with those plus and minuses, which causes there to be really a little air pocket in the middle of each little ring of water molecules as they freeze, which makes water ice less dense than liquid water, so ice floats. If ice didn't float, then water would freeze from the bottom up like most other compounds. All the fish would be pushed up to the top and they would die in the winter. And you know that if all the fish and all the life in the oceans and the rivers and stuff die, then we all die because of the web of life. You learned about that in elementary school, I'm sure. Okay, you're going to do the lab. You're going to make a polymer, which is really fun. This is common stuff. The borax solution you find in the laundry aisle. It's just borax powder. You make a little solution of it, add some of it to some water. You don't really have to measure it. Just dump it in there, stir it up. There'll still be powder on the bottom. Pour the liquid off the top. Add it to your glue and water, and you'll get to make slime. It's very fun. And if you want to ramp it up, there are a bunch of more slime recipes out on the internet that are really fun ones that like use shaving cream and stuff like that. All right, so that is this chapter. Read it, do those problems, skip the stuff that's the algebra, I keep doing it, the Chem 2. And like, share, subscribe. Come back next time. And remember, science is great.